There are these creatures that came from off-world. These are outsiders. NASA, famous for its historic revelations, has, as of late, uncovered that this new planet isn't simply captivating because of its size. What's more, its area, but additionally on the grounds that it shows lights that give off an impression of being counterfeit. Are we very nearly revealing secrets that could change our comprehension of the universe? Could this revelation mean there is life on other planets? Go along with us as we investigate NASA's interesting discoveries and uncover the reality about these phenomenal lights. In 2007, NASA sent off the Dawn rocket with a mission to investigate probably the most fascinating objects in our planetary group. Dawn was remarkably furnished with 3 ion motors, permitting it to embrace an exceptional excursion. Dawn's excursion began with a 14-month study of Vesta, the second-largest space rock in the belt. During this time, Dawn sent back definite pictures and information revealing Vesta's complex surface and various land histories. In the wake of finishing its mission at Vesta, Dawn set out on the second and maybe most interesting piece of its venture, a detailed investigation of the dwarf planet Ceres. Because of its ion motors, Dawn had the option to leave Vesta's orbit and set out to reach Ceres, an accomplishment that traditional chemical drive would have found testing. These motors provided a constant, delicate push, permitting Dawn to travel tremendous distances proficiently and go into a stable orbit around Ceres. Found in 1801 by Italian cosmologist Giuseppe Piazzi, Ceres is the largest object in the space rock belt between Mars and Jupiter. For a long time, it was viewed as the littlest dwarf planet in our nearby planetary group until its renaming in 2006. With a breadth of around 950 kilometers, Ceres is the largest and most massive body in the space rock belt and one of the most captivating due to its interesting attributes. As Dawn moved toward Ceres, researchers enthusiastically anticipated the first detailed pictures of this baffling world. They viewed as bright spots dissipated across its surface, most outstandingly in a huge pit now known as a crater. These bright spots ignited quick interest and speculation within established researchers. Previously Dawn's mission, the best picture we had of Ceres was a fuzzy, low-resolution image taken by the Hubble Space Telescope. Researchers knew pretty much nothing about this dwarf planet, and the possibility of at last getting a nearby view was exciting. What mysteries would Ceres uncover? What new discoveries awaited? The mission vowed to improve our comprehension of the planetary group's development and the role of water in molding planetary bodies. The brilliant spots on Ceres are unlike anything seen on different space rocks. They appear to be made out of highly reflective material, conceivably salts left behind by sublimated water. This seeing alluded to the chance of cryovolcanism on Ceres, an interaction where volatiles emit with water or briny fluid instead of liquid stone. However, what precisely are these strange lights, and what do they uncover about the nature of Ceres? Could they be proof of continuous geological action or something significantly more rare? Ceres stands out from other heavenly bodies in the space rock belt due to its size, mass, exceptional composition, and potential for water and ice. Unlike typical rocky space rocks, Ceres has a composition more akin to a comet, suggesting it holds more secrets about the early solar system than we ever envisioned. Following 2 years on the way, the Dawn rocket at long last began its approach to Ceres in mid-2015. This second marked a huge achievement in the mission as Dawn prepared to deliver humanity's most memorable close-up perspectives on the largest object in the space rock belt. As Dawn moved closer, the pictures of Ceres developed progressively detailed, offering brief looks at a world that had previously been covered in mystery. The first pictures uncovered a surface spotted with craters, demonstrative of a long history of impacts. However, it wasn't simply the cavities that grabbed the eye of researchers and space fans alike. Among these elements were the baffling bright spots that strongly stuck out against the more obscure rocky landscape. As the pictures kept on working on in resolution, mainstream researchers hummed with speculations about the nature of these bright spots. Were they ice patches reflecting sunlight, or might they be something significantly more fascinating? Hypotheses ranged from mineral stores to expected indications of cryovolcanic action. Incredibly, closer examination uncovered that the most splendid spot was not a solitary substance but instead a group of a few unmistakable spots. This discovery only grew the mystery, and the speculation that these were stores of salts left behind by sublimating water gained footing. This would suggest that Ceres had, or still has, some form of geological activity capable of bringing water or briny fluids to the surface, where they immediately dissipate, leaving bright reflective buildups. These discoveries challenged existing ideas about Ceres, portraying a more unique and complex world than previously imagined. The presence of such features alluded to the possibility of subsurface water or briny pockets, which could have significant implications for how we might interpret the potential for life in our solar system. Yet what makes Ceres unique from other planets? Ceres is an intriguing planet, often described as an icy world with a rocky yet permeable surface. Unlike most asteroids in the belt, which are principally made out of rocks and metals, Ceres stands out due to its unique arrangement. Its surface is a mix of water ice and hydrated minerals, including clays and carbonates, which give it a distinct, less dense structure compared to its neighbors. This composition suggests that Ceres has a significant amount of water. The surface layer is rocky yet permeable, with ice and other volatiles trapped inside. This icy characteristic is more reminiscent of a comet than a typical asteroid, indicating a history that could involve a mix of rocky and icy materials. Digging deeper beneath its surface, Ceres reveals many more interesting aspects of its composition. The dwarf planet is believed to have a differentiated interior, comprising a muddy mantle and a core. The mantle is thought to be rich in water ice, accounting for roughly half of Ceres' total volume. This mantle, a blend of rock and saline solution, surrounds a core that could be made out of denser material, perhaps silicates. The presence of such a large amount of water ice suggests that Ceres might have once harbored liquid water, particularly if its core was warmed by radioactive decay early in its history. This internal structure sets Ceres apart from its asteroid neighbors and also raises intriguing questions about its potential for geological activity and the role of water in its evolution. However, that is not all. The discovery of ammonia clays on Ceres implies that the dwarf planet may have formed in a colder part of the solar system and migrated inward. The presence of ammonia can lower the freezing point of water, supporting the presence of subsurface brines. These insights into Ceres' composition and history not only enhance our understanding of this fascinating dwarf planet, but also provide valuable clues about the processes that govern the formation and evolution of icy bodies throughout the solar system. Cryovolcanism is a captivating and somewhat obscure geological process, especially when contrasted with the more familiar volcanic activity we see on Earth. Unlike traditional volcanoes that eject liquid rock, cryovolcanoes, also known as ice volcanoes, emit volatiles such as water, ammonia, or methane. These substances can exist as liquids or gases in the supercold conditions where cryovolcanoes are found. On Ceres, the cryovolcano operates by allowing water loaded with dissolved salts to reach the surface. When this salty water interacts with the vacuum of space, it rapidly sublimes, changing directly from a solid or liquid state to gas. This process leaves behind bright, reflective salt deposits. The most famous of these bright spots is located in a crater named Decatur, also known as Spot 5. This region has earned significant attention due to its high reflectivity and occasional mists observed by the Dawn spacecraft. These mists are believed to be caused by the sublimation of water, which suggests that cryovolcanic activity could still be ongoing or has occurred relatively recently. In addition to Spot 5, Ceres has several other bright spots, each with its own unique characteristics. These spots are not limited to a single region but are dispersed across the dwarf planet's surface, showing that cryovolcanism might be a widespread phenomenon on Ceres. The presence of these bright spots highlights the unique nature of Ceres and raises significant questions about the potential for life in our solar system. The dynamic and active nature of Ceres challenges past assumptions that it was a geologically dead world. As the Dawn spacecraft provided more detailed images of Ceres, an abundance of surface features began to emerge. The outer layer of Ceres is dotted with a variety of craters, each telling a story of the dwarf planet's history. Some craters are relatively shallow and eroded, indicating an old surface that has been subjected to various impacts over billions of years. Others are more well-preserved, with sharp edges and deep basins, suggesting more recent impacts. Interestingly, the number of craters on Ceres is less than initially anticipated. This discrepancy hints at geological processes that may be renewing the surface and erasing evidence of older impacts. One hypothesis is that Ceres' icy composition allows for a form of cryovolcanic resurfacing, where subsurface materials intermittently well up and cover old features. This ongoing geological activity suggests that Ceres is not a static world but one that has been and potentially still is actively evolving. Additional evidence of geological activity on Ceres comes from the observation of cracks, grooves, and box-like structures on its surface. These features indicate that the crust of Ceres has experienced significant stress and deformation. Some of the cracks appear relatively young, possibly only a couple 100 million years old, suggesting that the crust is still dynamic. The grooves and boxes on Ceres likely formed as the crust was stretched and pulled apart, while ridges of mountains and compression features show areas where the outer layer was pushed together. These contrasting features offer a glimpse into the complex processes that have shaped Ceres over time. The presence of a large dome-shaped mountain in one of the craters suggests the possibility of internal pressure or upwelling of materials, possibly related to cryovolcanism. This feature, along with the extensive network of cracks and depressions, points to an active and evolving surface. The Dawn mission's observations have also uncovered intriguing surface compositions beyond the bright spots and reflective salts. NASA's data has revealed a range of surface materials that are critical for understanding Ceres' geological history. For example, certain regions on Ceres show a dark, fine-grained material that stands out sharply from the brighter salt deposits. This darker material is believed to be a type of carbon-rich substance, possibly organic, which adds another layer of complexity to Ceres' composition and suggests potential for prebiotic chemistry. The interaction between these materials and the icy surface may play a role in the chemical processes occurring on Ceres. In addition, the detection of organic compounds on Ceres has sparked significant interest in astrobiology. Organic molecules, which are the building blocks of life as we know it, have been found as carbon-rich compounds. These discoveries are particularly exciting because they suggest that Ceres could have conditions suitable for the formation of more complex organic molecules. The presence of these compounds opens up possibilities regarding the potential for life, or at least the building blocks for life, being present on this dwarf planet. Another notable feature is the vast number of mysterious dome-shaped structures on Ceres. These domes, some reaching heights of up to 6 kilometers, are believed to be the result of subsurface processes pushing up material through the crust. Their shapes and sizes suggest that they may have formed from cryovolcanic activity or from internal pressure driving materials upwards. Understanding these formations is essential for unraveling the geological history of Ceres and its internal dynamics. Moreover, the gravity data collected by Dawn has provided insights into the internal density distribution of Ceres. Variations in gravity reveal the presence of differing layers within the dwarf planet, indicating that Ceres' interior may have complex structures, including a potential subsurface ocean or briny pockets. These discoveries are crucial for understanding the thermal history of Ceres and its capacity to harbor conditions conducive to life. Overall, the Dawn mission has not only expanded our knowledge of Ceres, but also transformed our understanding of small celestial bodies in the solar system. As more data is analyzed, researchers hope to further unravel the mysteries of this intriguing world and its potential to shed light on the broader processes that govern planetary formation and evolution. The findings from Ceres highlight the complexity and diversity of planetary bodies, challenging previous assumptions and opening new avenues for exploration in the search for life beyond Earth.